general rCB market growth in Asia and globally. I think one topic, I'm in recovered carbon black for 12 years now, and recovered carbon black and carbon black. And one big topic is the question, what is difference? What are the drivers, business drivers between Asia and Europe? What are the commonalities? What are the differences? So this is the agenda. We're going to talk a little bit about the community. And the community really of the conference has been growing. As I told you, 2018, small workshop, 70 people. And we've been continuously growing our community that is interested in recovered carbon black companies, tire companies, petrol companies, of course, technology suppliers, engineering companies. Now we are a community of around about 500 delegates across the two conferences. You might know last year we branched out to rCB Asia. Before we had only the conference in Europe. And it's good to see that actually there's a mix over. There's a lot of Asian colleagues going to the European conference. Here, there are a lot of European colleagues as well.
What are the business drivers in the West and what are the business drivers in the East? And in the last 10 years, I really started to change my mind. I thought the main region driving the business is Europe with its sustainability. Now I think the business driver is Asia because I think it's much easier to implement business in Asia. Here's a quotation from Florent Menegaux, the CEO of Michelin, which he did last year on the Moving On summit in Brussels. And he said, ecology cannot be without economy. There will be no circularity without a business model. I think this is really key. And I believe the economy comes first and then the ecology comes because we need to make the ecology affordable. We need to be able to afford the CapEx. Our customers need to be able to afford our products, the TPO and the rCB. In the West, there is a lot of business driven by sustainable aviation fuels, renewable diesel, so the circular feedstocks for the drop-in sustainability. The problem we have is that many of the technologies, aviation, there will be no propulsion, no new propulsion innovation for the next foreseeable 10 years. So the only thing we can do to greenify aviation is to change the feedstock. And this, of course, reminds us what the carbon black industry does. The carbon black industry, the furnace process, is capable of producing 95% of all carbon blacks that we need. So the furnace process is the most flexible process we have for carbon black. But how do we make it greener? And of course, the easy solution is to change the feedstock. 65% of the global tire industry is focused on rCB. I did a survey in 21 for an Indian client. And they were interested, okay, what does the tire industry want to have for circularity? Powder, reclaim or devulcanized materials, or recovered carbon black? And so these were 11 tire companies representing 65% of the tire industry. Most of the companies actually said they see a lot of potential in rCB because you can have the highest flexibility, put a little bit into several compounds, whereas reclaim and powder have very specific applications, and you cannot add sufficient volumes to really drive circularity. Now, recovered carbon black, an application engineered product. This is not currently the terminology we have in ASTM. We'll have an update from Peter Tahar. Peter, where are you? Welcome, Peter. Really honored that you're here. I think ASTM D36 is really key to the development because as of now, recovered carbon black is not yet a commodity, and we want it to be a commodity. And the implication for that is that we might have the wrong business process. We might want a make-to-stock business process like the furnace carbon black industry. We do have a make-to-order business process because recovered carbon black cannot just drop in, replace furnace carbon black. We need to adjust the application a little bit. So the interesting question is, if we have char, as you might call it, which comes out of the pyrolysis, And what is the process to get rCB? Is it just milling and pelletizing? And I would say, no, it isn't, because we have to start at the beginning. For the rCB, the first process is we have to select the tires, because if you don't select the tires and get like a chemical consistent feed into the pyrolysis, it will be very difficult to have a consistent recovered carbon black. Then, of course, we need the pyrolysis. And the learning here is that the processes gravitate towards continuous processes. And what is important is we need to drive off the volatiles. So the polymer rests that are sticking on the rCB, we need to get a dry rCB. And then, of course, we have the refining process. Here we have in the Expo, we have Neumann Esser, we have Hosokawa, who are both offering back-end solutions. There's other companies and other milling companies. So really, we have three key processes for the recovered carbon black. And we cannot think that we make any char and then just milling of the char will make a recovered carbon black. And I'm trying to convince the community, I'm trying to convince you to change the terminology for rCB away from a recycling terminology to a more application and purpose engineered terminology, which, by the way, we have for the furnace carbon black. The terminology, ASTM terminology for furnace carbon black says it's an engineered product. We need rCB to be an engineered product, because the tire makers, we're tire makers here in the group. So the tire makers, they will confirm they need a consistent, reliable product. rCB composition. So a little bit more of what we already discussed. This is a very old slide, which was actually presented by Peter and myself in the Carbon Black World Conference 2018. And it's really, I get back to that scheme so often. And it's important to know rCB is a mixture of carbon blacks from the tire. And then we have some contamination, some payload, some inorganics, ash content. We have volatile hydrocarbons, and we have coke or carbonaceous residues. And all of this payload we need to reduce. Really, we want only a mixture of carbon blacks. And there's one part, the carbon blacks and the ash, that depend on the choice of the tires. So we need to select tires. We can select tires manually. You can say, okay, so we prefer truck tires, because truck tires generally have a more favorable chemical composition, nice 100, 200 carbon blacks. There's no silica in truck tires. There's natural rubber, which is good for the tire pyrolysis oil. But then, of course, I see the future in true tire sorting, because the passenger car tires have the widest spread of chemical composition. There is, winter tires, summer tires, all-year tires. There is fuel saver tires with a lot of silica. There's regional differences. Tires in Asia might not have as much silica as in Europe. If you take European tires, you have the highest ash content. So maybe importing tires from Europe is not the smartest thing. Although some of the companies that do rCB here in the group are already at the limit of getting enough tires. So importing tires might be a topic for you. And we'll discuss that later on in the panel and in the conference, of course. Now, I will not get through that slide. That's also a slide that you might have seen several times. Just to say, the pyrolysis is the core process, but is only one process that is required. It's a complex process to make rCB. And that is also why I like to look at our industry as the recovered carbon black industry, not the tire pyrolysis industry. And I think recovered carbon black is really unlocking your business, because it might be easy nowadays to sell the oil. But then what do you do with the 40% remaining mass balance of the recovered carbon black? And the recovered carbon black is most difficult to sell, which is exactly the reason why we're here in the conference and sharing our knowledge and our developments. rCB standards, mentioned it already. Without standards, rCB cannot be a commodity. I found it interesting last year in Qingdao to see that the Chinese carbon black and rubber industry agreed on recovered carbon black specifications. Interestingly, the specifications were iodine number, oil absorption number, and tensile, which we know from carbon black. And I found this a little bit counterintuitive. And in the car with my friend Sky from Goodyear, we discussed the tests. because I believe, and maybe Peter would agree, and the people of the trade would agree, the iodine number for rCB is not the key test, and the oil absorption number might not work. And the tensile gives you an idea, but now there is much more specific tests for the recovered carbon black, which are needed. However, any specification is good. Everybody in carbon black knows that the carbon black classification, the D1765, has two tests that don't work either. The iodine number is falsified by the surface groups, and the oil absorption number is replaced by the crushed oil absorption number for furnace carbon black. So I would say any specification is better than waiting for the best specification. ASTM, rCB standards and classification are in development, so we'll hear from Peter a little bit later on. I believe one of the key ingredients for success in rCB and success in the circular industry are ecosystems. So I'm talking about collaboration and integration along the supply chain. One example is Black Cycle. Now, Black Cycle, you might argue, was a bit like a sandpit project, like a European funded project, and not an operational, but they showed the concept. Interestingly, Black Cycle did not focus on rCB, but they made TPO in Pyrum and Greenbal in Spain. And then the oil was used for circular carbon blacks at Orion Engineered Carbons. And that was still copied or inspired the Korean Black Cycle, and our friends at LD Carbon can tell us about it. So collaboration really drives forward the business. And Black Cycle was super inspiring, although it did not focus on rCB. And the whole supply chain, now a big topic is the availability of the ALT feedstock. So any collaborations, and we see integration into ALT collection. Big companies like Circtec have acquired Granuband tire collectors in order to be closer to the feedstock. Because if we don't get the right feedstock, we cannot make good TPO or good rCB. Now, rCB supply growth. This is the only quantitative slide I have, and this is from my report I'm writing together with Paul Eiter from Notch Consulting. And I'm looking here at growth in Asia Pacific without China. And that has a reason, because China has humongous capacities of everything. And those capacities generally, they are used with a very low utilization rate. So the capacity might be misrepresenting the actual production and the actual availability of products. In China, there's at least 3 companies with a capacity for converting 600,000 tons of tires. So that would make you believe that there's a lot of volume of rCB available. So here I'm looking at the growth of the rCB supply. And this is the rCB supply with my glasses and Paul's glasses. There might be actually more, but there might be companies we don't know, or companies of whom we think they don't make rCB, they make char. So the build up in Europe from this year to next year will have a growth from 60,000 tons availability now to 133. So that's plus 73,000 tons rCB. Many big sites in Europe are being built. Circtec in Delfzijl, for example, Infinitaria in Uddevalla in Sweden. So it is very, very positive. It's very clear that building capacity in Europe is much more difficult than in Asia. We have the challenge of the regulations of getting permits, and it's much more difficult to build anything in Europe. Asia without China, the growth is 120,000 to 153,000. I think with what I learned still this week by my visits, we might correct that and include more projects, include more companies. There might be even higher growth in Asia. But generally, when we look at the chart, this chart is going to 2030. A very positive development for recovered carbon black availability. And for a tire maker, it's very important to have that volume. A tire maker can do nothing with just 1,000 tons rCB. You can only do racing tires that are produced in hundreds instead of millions. A typical car tire is produced in numbers of a couple of millions or tens of millions, and the tire maker would need tens or 20,000 or 30,000 tons of filler material to produce those tires. So, quick summary, I think rCB is possible. I see very good progress of the industry. I see more development and more capacity development in Asia, and I really like to see that Asia is developing rCB as strong as it is. Europe is fighting strong. We have a couple of topics still: end of waste, REACH, and the permits. European capacity is being built, albeit a little bit slower. Many thanks.
If you have not been to rCB Asia, you can still attend rCB Europe in November.